How's it going, everyone? Welcome, Gabriel Gonzalez here, and today let's continue to read about the chapter 3, which is the digging into the root of the JavaScript, which is part of this book written by Kyle Simpson, that you don't know GS yet. And here we just explore is this different, or we are exploring is the root of JavaScript. What is JavaScript? Serving JavaScript. And well, actually, in today's video is to understand is the inner JavaScript characteristic that is virtually in every line of code we write. Okay, so the idea is not going to into this extensive, as they mention here. Okay, so this materials is not an exhaustive exposition to the language. That's what the rest of the book series is for, but it's just to get us started on in becoming more comfortable with the JavaScript, with the feel of JavaScript, and it is ebbs and flows, right? So first we talk about is the iteration. Okay. So on the iteration, because most programs are built to process huge amount of data and they take decision on that data. So the way how we now create this particularly algorithms that help us to deal, the way how we write is these algorithms to manage these huge collections of data, or to manage and process these huge collections of data. It is crucial for us to understand is that the algorithm we write will have huge implication in how can we read that, and therefore it will impact is on the on one of the most common things that we do here in JavaScript. So this is why it is this exploration is all about, right? In the iteration, and because the standard way of consuming a collections of values, each one at a time, instead of having the entire data sets and then iterate through that, we cherry pick is just by chunks of data, and then start to process each one of them, and go to the next one and start to process each one of them, and to the next one, and so on and so forth. So you can think of this like when you put things on your fridge. All right, you have is for the vegetables, fruits, dietary products, and so on and so forth, and you then, well, daily are going to consume those items. Okay, you have the milk, you have the butter, perhaps, or some Parmesan cheese. I really love about Parmesan cheese, so I get the Parmesan cheese a little bit, and then some kiwis, bananas, some cabbage. All right, and as long as I have this in my fridge, I'm gonna be able to get that data to do one thing in specific, and in this case is to prepare this meal, to make this preparation, to make this, to process this. And I really love about this example because it actually exemplify is what is all of this. All right, so this fridge example or metaphor, okay, where you have all of these things already sorted, okay, in your fridge. So vegetables, fruits, dietary products, and then you cherry pick each one of them to process them to, well, some of you may say, hey, I want to make some decisions on this food. I want to enjoy this food. I want to actually get the value out of this food. some nutritional values. All right. So this is why I'm actually cherry picking specifically this one. I have all of this, but no. I want this to make this salad, this one, or I want to make now a a beef steak or a rough beef, right? Or I want to make is just a chicken breast, or I want to make a lunch, or I want to make this one. Okay, but this processing here is something that is much more tangible, and in the context of the JavaScript and the iteration, all right, this kind of data that we want to process is pretty much like this, right? You have these huge data sets that you want to consume is each one of them, all right, to process and then act upon that data. So again, the traditional way to, or the standard way that has been around over the decades, which is a part of a pattern, the iterator pattern, which is now a behavior like this. Okay, hey, you have get next, and it has more, all right, which is useful when you don't know about the data structure of this. Another real analogy of this is to say, hey, if you want to navigate through a place, right? Whether it is with each one of them, if you plan to visit Rome for a few days and visit all of its main sites and attractions, but once there you could waste a lot of time walking in circles, unable to find even the Colosseum. All right. On the other hand, you could buy a virtual guide or your smartphone and use it for navigation. It is smart and inexpensive. You could be staying at some interesting place for as long as you want. And the third alternative, you can spend some of the trip budget and hire a local guy who knows the city like the back of his hand. The guy will be able to tailor your tour and so on. All of these options, the random directions born in your head. The smart navigator and the human guide act as an iterator. Okay, act as a um, so act as somebody that's guiding you through do this. All right. Okay. So where with our example here, okay, um, where I'm looking is from the point of view. I'm looking is for the point of view of the um, of what you're going to prepare, what you're going to process, because this is what the end goal of all is what the end goal of a program or the most programs right now. Okay, so the iterator is going to act on behalf of that. It's going to help us here is to navigate through a sequence or to navigate through the data, to navigate through a map, okay, uh, and then process that data. So here the Kyle system is mentioning is that because this is a standard way to process and consuming data, all right. So the ideal is that it is more common and helpful to iterate the data source progressively and handle the collections by processing the first part and then the second and then the next and so on, rather than handling the entire set all at once. So imagine a data structure that represents a relational database select query, which typically organizes the result as rows. Okay, if this query has only a one couple of rows, you could handle the entire result set at once and assign each row to a local variable and perform whatever operation on that data were appropriate. But if the query has a 100 or 1,000 of more rows, you will need an iterative processing to deal with this data. Typically a loop, exactly. So the iterator patterns define a data structure called an iterator that has a reference. The iterator pattern define this this helper that will allow you. You can think of this helper, right? this these things that will allow you to navigate through your entire data sets one at a time. Okay, so hey, I would like to go to this place, hey, I want to look to another place, and so on and so forth. So an iteration is okay, it makes a lot of sense here, but I compare that iteration with processing. And I do this with the first example because it's pretty much like that. All right. So okay. So this iterator pattern, as they mention here, define a data structure called iterator. Okay, which is this. Defines a data structure called iterator. A data structure. And remember that this data structure or classes, like in this case, is just describing is this custom type or this custom value data structure that has its own data and methods that we can operate on that data. So when you talk about is this data structure here, okay, it means that this is a type of value, all right, that is representing something. In this case, a value, but it's this custom value that had its own data and its own methods that operates on that data. So, so yeah, okay, okay. So the iterator pattern describes a data structure like this, exactly. So the iterator data structure describes a data structure like this, okay. Exactly, describes a data structure like that. That has a reference, so that data structure has a reference on the underlying data source, okay, the iterator and the concrete iterator, right? So it has now a reference of the underlying data source. The iterator interface declares the operations required for traversing a collection, fetching the next element and retrieving the current position, and restarting the iteration. And then you have is this the concrete iterators implement a specific algorithm for traversing. Oh, the interface is defining is the contract. Declares the operations required for traversing a collection. Is declaring is the contract here, and the concrete iteration, which is defining is the series of steps. Concrete iteration is implement a specific algorithm for traversing a collections. So the iterator object should track the traversal progress on its own. This allows several iterators to traverse the same collection independently of each other. Exactly. This allows several iterators to traverse the same collections independently of each other. The collection interface declares one or multiple methods for getting iterators compatible with the collection. Okay, note that the return type of the methods must be declared as the iterator interface, so that the concrete collections can return various kind of iterator. And the concrete collections return new instance of a particularly concrete iterator class each time the client requests one. You might be wondering, where's the rest of the collection code? Don't worry, it should be in the same class. It is just that these details are crucial to the actual pattern, so we're omitting them. And the client works with both collections and iterators via the interface. The way the client isn't coupled to the concrete class, exactly, is not coupled to the concrete class. I, as a consumer, I don't care about with the algorithm that you're using. And typically, clients don't create iterators on their own, but instead get from the collections. Yes, in certain cases, the client can create one directly. For example, when the client defines its own special iterators. Holy moly! And this is the call. Okay. hmm But here is defining is the class, all right, which is this custom type that implements the profile iterator, which is this contract. Exactly. It say, hey, I'm gonna define this new custom data type, custom type, okay, that implements this contract, all right, and this contract must contain is well this two method in this case, right? So here it defines this private method that needs to, okay, so Facebook's and Facebook, all right, whether it's all of this uh, data that needs to uh, somehow is control or to keep track or to know about it, all right. And then the construction, which iterate all of this, it receives the Facebook, it receives the profile ID, and it receives the type. Okay, and then it say, hey, this private method lazy init is if the catch is null. So if you don't have any on the catch, I want to actually store is the entire social graph request. Holy hell, do the entire value of this social graph. Okay, this is to lazy init. It might take quite a lot. If you can think of the social graph, if you think, oh my god, this might take. Each concrete iterator class has its own implementation of the common iterator interface. Exactly. So each concrete iterator class, like this, has its own implementation of the common iterator interface. Whether it's this, if you have more, all right. Well, let's go to now is get the current position in that catch, and that'll be is our result, and then update the current position. Okay. And then it's gonna do that anytime you're going to get that until there is no more, right? And it say, hey, you have more. I'm going to initialize this, all right, and then I'm going to return is this one. You say, hey, let me actually check what I have in the catch, okay? And okay, let me actually check what I have in the catch in this local container, okay, of this entire structure or this entire data set or this entire spreadsheet, okay, of all of his data, okay. Let me see what is the current position, and if that is the less than the entire spreadsheet, some sort of speaking, data structure, good. I can continue to. If it's not, it's like, now it's done. Okay. And here's another useful trick. You can pass an iterator to a client class instead of giving it access to a whole collection. This way you don't expose the collections to the client. And there's another benefit. You can change the way the client works with the collection at runtime by passing it a different iterator. An iterator objects traverse the collection independently from other iterators. Therefore, it has to store the iteration state. Class social media is the method sends Oh, this is another implementation. All right. Here, the application class configure collections and iterator, and then pass them to the client code. Class application. There you got is this two values that we want to store. This custom type, as you can see. That despite the data structure despite the underlying data structure, I don't care about that. I care about that this is a value, okay? Uh, and this value is representing is this internal state of the application, all right? So this value that is representing is the data structure might be. It say, hey, this is the config method, and say is if working with Facebook, this.net is equal to the new Facebook. Is working with LinkedIn, this is okay. So regardless is the data structure here, you can actually use this. Or this dot spammer is the new social spammer. And the method sends pans to friend profile is iterator and send pans code. Applicability. Use the iterator pattern when your collection has a complex data structure under the hood, but you want to hide its complexity from clients, either for convenience or security reasons, most likely for security reasons. The iterator encapsulates the detail of working with complex data structure, providing the client with several simple methods of accessing of collections elements. While this approach is very convenient for the client, it also protects the collection from careless or malicious actions the client will be able to perform if working with the collections directly. Use the pattern to reduce duplication of the traversal code across your app. The code of non-trivial iteration algorithms tend to be very bulky. When placed within the business logic on an app, it may blur the responsibility of the original code and make it less maintainable. Moving the traversal code to designated iterators can help you make the code of the application more lean and clean. Use the iterator when you want your code be able to traverse different data structures, or when type of these structures are unknown beforehand. The pattern provides a couple of genetic interface for both collections and iterators. Okay, it provides both of this interface, this contract, how they should look like. Okay, so what is the iterators and what is the collection? Given that your code now use this interface, it is still work if you pass its various kind of collections and iterators that implement this interface. Applying the pattern can be an overkill if your app only works with simple collections. Using an iterator may be less efficient than going through elements on some specialized collections directly. It's a single responsibility principle, open and close principle. You can iterate over the same collections in parallel because each iteration object contains its own iteration state. And then you got this. Relations with other patterns. You can use iteration to traverse composite trees. You can use factory methods along with iterators to let the collection subclass return different types of iterators that are compatible with the collection. You can use memento along with iterator to capture the current iterator state and roll it if it is necessary. You can use visitor along with iterator to traverse. But again, I mean, this is good. Okay, you can combine this visitor with iterators, and visitor is a behavioral design pattern that lets you separate algorithm from objects on which they operate. But again, I'm going to be acute of what we need to understand here, and that is the iteration. Okay, and now here, when you dive deep into the ECMAScript of the iterables, e- of the iterable, right? The iterable interface, like this, all right? It say, hey, the iterable interface include the property described in the table 80, and this is now an iterable, and the iteration that come from control abstract operations. You have now iterations, you have the iteration helper objects, iteration. Okay, all of this is iteration. And then you have the promise objects. Okay, this is quite interesting that we actually are looking at this, because this is describing is the this aspect of the language. All right. So far we have describing is what is JavaScript, right? Along all of the things that I mentioned before. So what is that JavaScript? Who made that? Who owns the legal trademark? Who oversees the technical spec, which is this, which is the TC39? What is the purpose? What is the role? Who made that? Uh, why some certain JavaScript engines implementations decide to sometimes not to follow, not to stick to the spec, because the reality of the web is different to the spec, and because of this mismatch, which is something that happening in a lot of developers in JavaScript, is something that you have all of these different environments where you can run your code, the client, the server, the what's next? Yeah, the client, the server, light bulbs, robots, and the only reality that matter is the web. Okay, so despite that you have different JavaScript environments, and in the case of the dev tool, why the console is not a truly Java or a spec compliant JavaScript environment, it is because, well, it is things that's going on behind the scenes. For example, in the case of use strict, how it actually works in a true JavaScript environment versus here, or also how when you define variables and functions definitions, their names are appended to the window, among other things. Okay, but despite that, and that the TC39 wants to commit themselves to won't break the web. That's why they create now the polyfills. And how can we use those polyfill, which is something that I do find it is quite important and relevant. But in any case, in as we explore this area, this aspect of the JavaScript, and we look at how can we use the language to approach to, well, the terms approach is how can we, giving a problem, we can use this tool, right? uh, so for example is the object programming. So when the problem is about communication or collaboration, how object programming is the way to go. If your problem is about computation, how can we use now functional programming to guarantee the correctness of the program and the readability of that, somewhat of that. And also you have the procedures, and despite all of this, it's important to understand how JavaScript actually works behind the scenes. That this is a compiled language, and why the concern of this compiled language has been with the parse and the execution phase. So, for example, ASM was a precedence to show now that hey, JavaScript is a fast enough language by providing some hints to the engines, and then you have now games running on the browser at 60 FPS, all right? And why now WASP? It was the spiritual successor of ASM to say, hey, let's going to cut the parsing time, and therefore let's go to define this intermediary language, uh, assembly like, that help us now to execute the code in this particular environment, was environment, and how it became now a universal target compiler. And how we have is the strict mode, and what is the strict mode, which is a set of guides to uh, tell developers how to do things that the JavaScript engine has good chances for of optimizing and running your code. So, and then on the survey, okay, we explore about what is a program, that each program is a file, how JavaScript see programs, so JavaScript determine what is a value, what are the type of values, primitive objects, arrays, and functions, how you can determine those values, how you can now describe those values in the language, whether using is a declarative or via literals or held inside of the containers known as variables, and how we have different syntax forms of the language, uh, like the let, like the var, let, and const, and each one of them has its own way of allowing this variable inside of or held in this container you can have access to. All right, so pretty much when you put things in your fridge, you have now all of it organized in that. So if you have now fruits, vegetables, and dietary products in that particular order, so you know when you open that when you need to go, right? And the other is that how can we now is uh, understand that another way of defining variables. So for example, like the yes, so for example, like mm, so for example, like like the, yeah, how they put it, so how you can define, exactly, so how you can define is all the type of variables, right? Whether it's a functions declarations, or via is the parameters inside of a function, or when you have in a try catch. Also, what is a functions, how functions works in JavaScript, when you have a procedure and a function, and how that actually work, what are the difference in each one of them. All right, and then how can we now is uh, use the functions as values in our programs, and how now that unlock is new different patterns, the functional patterns. This is just to describe as the sections, and then the the comparison, so the equality and the coercion or the conversion of the type, which is something that is describing here. As you can see here is the abstract operations, followed by the data types value it is no so the data type, something that we mentioned, uh, and the coercion and the comparison, which is part of these abstract operations here, okay, where you have now, hey, how JavaScript, for example, compare elements or compare values, okay. So what is the algorithm and how that algorithm behave, whether it's a double equal, the triple equal, or the quadruple equal, which is the opia.s, for example, as you can see here, all right, is describing is this algorithms that happen without your permissions, and define is how this is going to be evaluated, right? How the double equal is going to be evaluated, the triple equal is going to be evaluated, and how most of the time the double equal uh, prefer is numeric coercion uh, on on when comparing that. Okay, the triple equal is now is only compare that per type. Okay, if they are the same type and value, all right, good. But there's some edge cases. To cover those edge cases, we have is the object that is, and this is just for comparing primitive. And when it comes to compare now objects, so because values when are compared are based on the identity, okay, which means is that they are unique to themselves. So there is no 42, despite that you can represent 42 in different systems, okay, but there is only one 42. So a good example of this is, so no matter how you define a 42, right? So no matter how you define a 42 here, the thing is this. So no matter how you define is like this. And the thing is this. No, is exactly. So no matter how you define is 42, right? Okay. So no matter how you define is 42. Holy hell. I'm impressed, but it's because I get all of this feedback from that. So no matter how you define is 42. Look at this. That's what the fuck. I wasn't expected. 10, 10, 10. So no matter how you define is um so no matter how you define 42, right? Whether it is here or you define is in an hexadecimal, which is no, something like is this. So it's this. So no matter how you define this, okay, whether it's in an hexadecimal or a binary, 42 still being 42. You like her. This is the representation of this entity, right? And it won't change. So that entity won't change, right? It's the identity of this. This is the realm of philosophy and that kind of stuff. But because of this, all right, because the way how now values are compared is by this identity, all right, and when you do things like this, you are telling to the language that is that to create now array behind the scenes. Hey, create two different arrays. It's pretty much like you're saying is this, all right. Hey, I want you to create now an array dynamically, and then hold that value here and do the same for this. I prefer to use let to avoid any confusion. Okay. So yeah, I prefer to use this. Okay. And then say, hey, I want to compare now array 1 if they are the same identity, all right, and they say no. However, if you for some reason say this, all right, So what it's doing is to say, hey, I'm gonna create now a reference, which is the way how now in JavaScript actually, unlike any other language, where you can explicitly describe is how you're gonna pass this value, how you're gonna pass, how you're going to assign this value, all right? Whether it's by copying it or by creating it as a reference. Here in JavaScript we don't have that. In fact, here in JavaScript we say, hey, the way to do this is per values. So when you're using a primitive, you are indeed creating a copy from that. And especially if you now assign to another value. So for example, in the case of this, oh my god. So in the case of this, right? In the case of this, it's either true because they're creating now a copy of this and they are comparing by its identity. But now in the case of arrays, all right, so when you are assigning, or pass a value, for example, to a function, so they are now passed is by reference, which is in this case is telling that this is true because now you are is passing is a reference. And because your passing is a reference, if you mutate the original, you say array.push with 1, and then you ask the question again. All right. So it remains a true. But if you for some reason modify is the reference, okay, say 2, and then you want to compare, right? That's why mind blowing. Oh, because it's shallow copy, bro. Because it's shallow copy. So array 1. So you are indeed modifying is the reference, all right? But in this shallow copy. So for example, if you do things like this, where inside of this, look at this. So all of this belongs to a single value, and because you have reference to this, if you mutate that value, it's going to be affected by all the reference there. That is my bandit. So for example, if I say this at the 2 position, I want to assign is this value, all right? If you do this, now they become is interesting. So array 1 is actually mutated. So what it's doing is that that value is being mutated. That value is being mutated. And another good example is this. So that value is being mutated. So if you do have, for example, this, all right, let's say now this is going to call this an object, object 1, okay, an object 1, an object 2. So for example, you have now is the name, okay, there you got it. And then you have is now, for example, address. And here you have now an SW, you say zip code, which is this, particularly in, you say, hey, street, it'll be lavage. All right. So if you don't want to compare that, they actually are the same, okay? So if you for some reason now mutate is the value on the name, if you mutate the value of the name, okay, it will also mutate is the reference. It also is gonna mutate is the value itself, and all the reference that have point to that. So this is it. This is this is interesting. You can see here. But if you, for example, now mutate, and if you mutate now nested objects, it will going to do this same. In fact, we created an object here. I didn't want to create that. Anyway, that won't affect that. So address.zip code, and if we mutate that, we say 1, 2, 3, 4, right? So we are now is mutating is the value, and all of the reference that points to update that value. So if we look at the object of one and say address and say the zip code, so yes, it makes a lot of sense. So this is one of the problem here with mutations, okay? And when you do this kind of stuff, you have to be careful about that. So if you want to create now a new copy, because back then the memory was quite expensive and limited, now we have the luxury of creating multiple copies of all of this without any problem, okay? And say something like this: hey, object.one, it's gonna go to this and say, hey, because now I want to create now an object from it. I want to now is create a copy of this. So I don't want to have is the same reference for this. So you say is this object.one is equal to object.two. You say no, this is false. But again, this is doing is a shallow copy, right? So if you want to exactly, because this is interesting because it's also saying, hey, if this is an object, and the question is that does object has the symbol that is? That's interesting. That's interesting. It doesn't have is it doesn't have that, bro. So we're exploring is this because as we now as we look at the again, just recapping in chapter 1 and chapter 2 and here the comparison and that kind of stuff is as we explore the way of comparing values and looking at the spec, how and when can we go to this, all right? Whether it's the same type, the same value, it's loosely equal, it's less than equal, all right? And some other operations such as the coercion, that is something that's going to happen, for example, in if and while is something that is going to happen, all right? And here is what's going on, and here's what is going to be converted, all right? All of this becomes these abstract operations. So testing and comparison operations is part of this, as well as operations on objects, okay? And as we describe these operations on objects, which is also describing is a group by, so on and so forth, right? And here they also is describing that not only that they are abstract operation or this algorithm that is going to happen without your permission, which is coercion, type conversion, and the equality or comparison, okay, as well as the operations on iterator objects. So operations on objects, okay, which is something that also happens without your permissions, okay, but expose is certain of these methods. You have the call, you have the construct. If it has a call, it means that this is now a function. All right. It has also the group by, and it also have the operations of iteration object, like this. An iterator record is a record value used to encapsulate an iterator, async or async iterator, along with the next methods. And here is what is implementing that. The iterator record. Get iterator from methods, and get iterator as we look at this. And we are exploring is this, okay? Because this is our operations that happen without our permission, okay? And why this is important. So this abstract operation, whether it's type conversion or comparison objects, or all operations on objects and operations on iterator objects, is because by looking at the iteration, which is this, okay? So by looking at the iteration here, to get iterator, the iterator records, is because we were looking is at the spread operator, or the spread element, that it say, hey, I'm going to evaluate any assignment expression, whether it's a condition, field expression, arrow functions, you know, left hand side, or any of this. And it say that if you call me like this assignment expression, if this assignment expression, when I evaluate and I get that value, and if that value that I'm getting here is looking to the iterator, it say, hey, if kind is async, then do this, but if not, it say, hey, let the method be the get method of the symbol iterator. And get method, it say, hey, this is an abstract operations on object, okay, that is going to happen without your permission, that say, hey, the abstract operation get method takes argument v, an ECMAScript value language, and p, exactly, is any ECMAScript value, right? You can imagine. And the property p, and returns either a normal completion containing either a function object or undefined. Okay, it's either a function object. Interesting. It returns either as a normal completion, either a function object or undefined, or throw a completion. It is used to get the value of a specific property of an ECMAScript value. So when the it is used to get the specific property of an ECMAScript value. What is the property of an ECMAScript value? When the value of the property is expected to be a function, it performs the following step when called. Let the function be the get v, and again, another thing here is the abstract operation get v that takes argument v and the property key, and return either a normal completion, an ECMAScript value, or throw completion, and it is used to retrieve the value of a specific property of an ECMAScript value. Exactly. It is used to retrieve the value of a specific property of an ECMAScript value. If the value is not an object, the property lookup is performed using a wrapper object appropriate for the type of the value. It performs the following step when called. It say, I would like to try to coerce that into an object. Okay? I will try to coerce that into an object. Convert that into an object. And it say, hey, if the argument that I'm receiving is undefined or null, this is not an object. But if bool, I'm going to now wrap this into an object, known as Boolean. Okay. known as boolean. I don't think that we have to object. No, I don't think we have is that. But we can do something like this. So this is a function to say, hey, 5, right? A number. Okay, this is to convert that into an object. So object is converting is attempt to do this. So whether it's a string, or whether it is a number, or whether it is a boolean, okay, and it's gonna return you that, okay, primary value, primary string, or if this is a big int, but at the end of the day, big int is like a string, you know, or if this is a symbol, right? But this is a symbol, and then you define it as a private value. Say, hey, private value. Or this is a symbol, right? But if this is a null, you say if this is undefined, you say if this is an object empty. So, but in this case, it saves that. It's trying to coerce that. So, if for some reason, once we convert that into an object, we get that an object, okay? So return is the get of this. So hey, I want to get the value given this property here. So once I get the value of that property, okay, if the function is either undefined or null, return undefined. So what it's doing here is to try to get if this is a function. Return if it's callable, all right, it's false, throw a type error exception. Otherwise, now it means that this is a function. So it says that, hey, return me this function. Okay, so I'm going to look at that object. If that contains now is the symbol iterator. If the method is undefined, throw a type error exception and returns a get iterator from methods. And that's to me quite interesting, because when it tried to use this spread operator like this, okay, the spread operator actually, let's say you have now several of this, say values like, you say number 1, so number 2, so you know, an object with certain properties, or to make more meaningful, a user object. You have now is the ID 1, the name, right, and the score, right, say 0. You want to assign this to a variable and held that value, okay. And the thing here is that if this is this, so because I don't know what's going on here, say user 1, I can say is this, it's say this is user, all right, but it's gonna call that on objects, okay, and it say, hey, if that object, when I'm trying to get that, it contains now the symbol iterator, if the method is undefined, throw a type error exception. So in this case, it's supposed to throw a type error exception, but the thing is, this does not. The thing is, it does not, which means that this iterator, as you can see here, is in fact now, this is in fact now an iterable. So user somehow must have is the symbol dot iterator in place, but it say, hey, it is undefined. So you can, another way to do is, hey, is the symbol dot iterator in user? It say no. That's why my blowing. This is why now this is when things get interesting, because as you can see here, it's saying, hey, despite that this is how this thing should be implemented, despite that this is the spec, not all of JavaScript implementations actually use that. So for example, if we go now to this spread operator, spread syntax here, so this actually works for this. And also for object literals, spreading object literal. And the behavior here is quite mind-blowing. All right. And the behavior here is quite mind-blowing. So it's like, okay. So the behavior here is quite mind-blowing. It says that symbol.iterator in user, you got this. It say no, this doesn't exist. But if you compare that, for example, into an array, it will tell you true, but not for objects. So somehow, okay, this object is converted. This is part, this is some of the thing that you are assuming. So somehow this object is now converted. So for example, you say the user, somehow this object is now converting into this once you do this, right? And I think that this is a very interesting example of how the actual spec says and what the current implementation is. So this just only tells you is this particular thing, that there is no thing, so there is no need to worry about that. It's quite relevant because it all boils down to say, hey, despite the best effort of the TC39 to guarantee that this is how the JavaScript should look like, JavaScript implementations, do some special reasons, usually legacy reasons, among others, political, you name it, they may decide to have something behind the scenes. And again, remember, this is not a JavaScript, it's not a strict JavaScript environment. It is a friendly JavaScript environment. So if you, for example, do this kind of stuff, okay, whether it's that entries or here, it's a yes, it is. It definitely exists. So if you take a look at this, because now it converts that into a collections, into an array of course that has the symbol iterator, that's exactly what it's doing. So I do find this quite revealing, quite mind-blowing, because this is somehow like it's telling that. It's like telling, it's like wrapping this. It's like the environment is detecting is that and say something like this, you know? And on the user one, you get is, well, some mirror representation of that. Some weird representation of that. Mm. So this is quite mind-blowing, mind revealing here. And as we explore about the iteration and how do we consume that, it makes a lot of sense for go into that. So we also describe is the iterables, all right? And how can we consume that? And how now there are iterables of different. So there are several values that has the iterator protocol built in, all right, and that is numbers and so on and so forth. And then we are going to discuss now closure, but in later on. Yeah, I'm gonna make a quick pause here. I'll be right back.